This is going to be objective 10-4. We are looking at percentages using the z-score table, which I have given you a copy of today. Okay. If you're watching this lesson, I'm going to put a copy of the z-score table in our Google Classroom under the statistics unit. So if you want to go and look at it, you can. Okay. A normal distribution of data has a mean of 66 and a standard deviation of 11. Okay. Find the percentage that a random value is less than 44. So here's my first question. Can you draw a bell curve? Yes, I want you to draw a bell curve that has a mean of 66 and a standard deviation of 11. Okay, I'm going to hit the pause button and let you do that real quick. All right, so I asked you to draw a bell curve. So this is 0, 1, 2, 3, and -1, -2, -3. Okay, so 66 goes in the middle, and we know we're deviating how? By 11. So if I'm at 66 and I take one step to the right, where would I be? 77, and then 88, and then 99. I always loved counting by 11s. They're so easy. And then I would be at 55, and then 44, and then 33. Okay? And I want to know the percentage that is less than 44. So here's my question. Let's mark 44. Okay? Do we see 44? I'm going to mark it, and I'm going to shade what I want. I want less than. So I want all of this, and I want all of that. Can someone give me the percentage less than without doing 2.45? How'd you do that so quickly? You know this bar is 2.35%, and you know this is 0.1, and so you can just add up your bars. Remember, we've talked about this before. Okay, so if it's exactly smack dab on the line or exactly in the middle, the picture, that's all you need to answer your questions. Any questions about that? Okay, so this answer would be 2.45%. The second question says, find the percentage that is less than 79. So let's mark 79. It's between 1 and 2. There's 79 right there. And I want all of this, all of this, all of that, that, and this little piece right here. My question is do I know what it is exactly? No. And that is where your Z table comes into play. Okay? This little baby right here, based on our Z-score, will give you the percentage less than any point on the bell curve. Okay? So what we need to do first is, in order to read a Z-table, what does 79 need to be in? Terms of what? It needs to be, that is your data value. It needs to be a Z-score. Does that make sense? This a Z-table, these are Z-scores we're reading. So we're going to take 79 and we're going to make it a Z-score. Okay? So what's my formula? Very good. Z equals X minus mu over sigma. And we're going to look for the Z-score. So what's X? 79. It's your specific data value. Minus the mean, which is 66 divided by 11. So, what is 79 minus 66? 13. And what's 13 divided by 11? Rounded. And here's what I'm going to tell you. You need to, this table reads by the hundredth. So that's 2 decimal places. Give me the Z-score rounded to the nearest hundredth. What would it be? Give me 2 places. 1.18, 1.18. Do you understand that? It's got to be 2 places. And you've got to be able to round, guys, because if you don't round this correctly, it's not going to be right. 13 divided by 11 is 1.18. Okay, so I have not read the table yet. Let me explain how so we know the z-score is 1.18. Your z-table, if you go down the side, that is your tenths. Do you understand that? So what am I going to read going down the side? 1.1. If you go across the top reads your hundredths. So what number is in the hundredths place value? 8. So you're going to go all the way across to 8. Do you understand so far? And you're going to meet them in the middle. So if I do that, if I go all the way across 0.8 and I go to 1.1 and I meet them in the middle, what decimal do I see? Okay, so all of this to the left is 0.8810. Now, if I ask for the probability, I'd be done. Remember, the probability is just the decimal. These are all in probability out of 1. But if I wanted the percentage, that's what B says. It says find the percentage. Move it 2 places, so what percent? It's 88.1%, or 88.10. I'm just going to put 0.1. 88.1%. Okay, to the left. Let me ask you a question. What if I said what percentage is greater? What would be on this side? If I wanted to know what's this side? If this side is 88%, what would this side be? Why would it be 100 take away 88? Because the whole thing is 100%. The whole kit and caboodle is 100%. And if this piece is 88, what's left over? What would be over here? 12%. You did 88 minus 100. Do 100 minus 88. Does that make sense? So here's the question. Cameron, you with me? Okay. So if I ask for the percentage less than, repeat after me. The table gives you less than. The table gives you less than. More than 2 people. The table gives you less than. The table gives you less than. One more time. We act like we love Mondays. The table gives you less than. So you need to understand that. This is always less than. If I want what's greater than, then you use this, but then just subtract it from 100 to get the other side. Okay? Any questions about that? All right. All right. So, look what it says. The table always tells you the percentage that is less than your data value. So, using our z-score table, we're going to identify the percentages that are less than each z-score. So, we're just going to practice reading the table. Okay? So, if I look at part A, do I need to give you a second to write all that down? Okay. I'm going to hit pause. Okay. So, here we go. Let's look at part A. Z equals 1.86. So, if we're reading our z-score table, what am I going to read down the side? 1.8. Does that make sense? You're going to read 1.8, read the tenths down to the side. So go down to 1.8. Everybody do this with me so you know how to read it. What are you going to go across to up top? 0.6, 0.06. So 0.9686. Now be specific with me. What is that? That's the decimal. That's the probability. It has a 0.9686 chance out of 1. Does that make sense? Of drawing that if I asked for the probability. Okay? But if I ask for the percentage, move it 2 spots, so what percent? 96.86%. Where is 96.86%? Like if I drew this on a bell curve, you with me? Here's 1, 0, 1, 2. Here's 1.86 right there. I'm marking it. Where's 96%? Where, though, on the bell curve? What does the table always give you? So it would be everything this way. Does that make sense? And that kind of makes sense. Have I shaded a lot or a little? Does it look like I've shaded 96% of it? Do you understand what I'm saying? Okay. All right, let's go to part B, 3.22. So if I go down to 3.2 and I go across the top to 0.02. So let's think about this. 0, 1, 2, 3. 1, 2, 3. So if I marked 3.22, it would be way out here. What would we consider 3.22? Like if that was actually my z-score, what would I be? So what would I be on the table if I'm actually all the way at a 3.22? I'm kind of off the table. I'd be an outlier. Does that make sense? I'd be that extreme case. If this were test scores, remember I said there's, you got to leave a little room on this side and this side for those extreme cases. Like if these were test scores, you got to leave a little room for that one student that never pays attention, sleeps through class, doesn't ever come to school, doesn't ever do the homework, doesn't care about school, and makes 20 on the test when everybody else makes an 80. You with me? Or if we've had this in the flip side, a test that's really hard and most everybody makes in the 60s and 70s, and you got to leave a little room on this side of the table for that one student that always makes 100 and everybody wants to be like, ugh. Does that make sense? So if I was a 3.22, I'd be way out here. Now, this says this is what did y'all tell me? 0.9994. So if I made this a 199.94. Where is 99? From this point, where is 99? That's everything over here. And does that make sense that would all be 99.94%? Because I've pretty much shaded what? The whole table except for that little piece right there. Do you understand that? Okay. So let's go to part C, negative 2.89. Now, you got to flip it on the back. Here's your positives on the front side. Your negative z-scores are on the back side. Yeah. So you use this place value right here. So you would use negative 2.8 going down the side, and you do use 0.9. And you have to be careful. Look on the front side. Where's 0.9? 0.09. All the way to the right side on the front, on the positive side. But if you look on the back side, where's 0.09? It's the first one. Do you understand that they're backwards? So you got to be careful about that. So if I go down to negative 2.8 and I go to 0.09, what percentage is that? 0.0019. So if I made that a percentage, it would be 0.19%. That's not a lot. Does that make sense on our bell curve? So this is 0, negative 1, negative 2, negative 3. Where's negative 2.89? Right there. So does it make sense that this is just 0.19%? That it's just that little bit. Okay? Any questions on that? All right, and then if we did negative 0.34, what would I look for on my table? I go down to negative 0.3. I go down to negative 0.3, and then I go across to what? What would I use up top? 0.04. So if I did that, what percentage would that be? So 0.3369, so roughly around how much percent?
No, it's 3669.
Oh, sorry, excuse me. Yeah.
Yes, it will.
Oh. It's definitely a Monday, isn't it? 3669.
Yeah.
So roughly around how much percent?
36.69.
36.69%. Okay. Any questions about how to read the table? Everybody got the positive side versus the negative side. Everybody got on the positive side, it goes from 0 to 9 up top. But on the negative side, it goes from 9 to 0. Okay, because that's a very common error. All right, so we've actually already done this part as far as normal distribution. This is part B. We've already done part B. So moving on. Oops, there might be an example too. Is there an example too? Oh, that example 2 was the ABCD. Sorry about that. All right, so let's take a look at this. Suppose that a study of how long it takes students to complete an exam has a mean of 80 and a standard deviation of 8. So here's my question. Can you draw a bell curve? Go for it. Okay, so this would be 90. No, just kidding. Sorry, 80. And each deviation is 8, so I would be at 88, then 104, then I would be at 72, and 56. And we're going to mark 90, because that's what I'm talking about. I encourage you to, because it will help you, especially when we get into shading less and shading greater. Mark 90. So here's 90. Is this one going to be good by the picture? No, why not? Because it's not on the line. It's going to be in between. So you're going to need to use your z-score and your z-score table. I want to know what's less than. So let's shade less. So I want all of this, 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 and that little piece right there. Okay? What's going to give me less than, by the way? What's going to give me less than? The table. Table gives you less than. All right, so let's change 90 into a z-score. So what do we have? So 90 minus 80 divided by 8. So what's 10 divided by 8?
I got
1.25. Okay, and it needs to be to the hundredth, 2 decimal places. Okay. All right, so let's go down the side. Everybody pick your heads up, please. I don't mean to be boring. I'm trying not to. Okay. All right, let's go 1.2 down the side on the positive side, and then go across 0.05. So what percentage do we have?
0.894.
So 0.88944?
Yeah.
Okay. And so that's your probability, right? So my question is, what percentage is that? 89.44. Is that what I've shaded? Is that what I want? Is this what I've shaded, 89.44%? Yes, because why? What does the table give you? You're less than. So that's what you want. Okay? Be careful. I keep asking you that because eventually what are they going to do? Ask you what the greater than is. And if it's greater than, then what would you do with 89%? Take it from 100. Okay? Yes, sir.
Yeah, so I get everything up to the point I get how you get 0.8
Mhm.
right? How do you get 89.14?
Because this is a decimal. You found that on your table. Are you good with that? Okay, so to make that a percentage, you just move it 2 spots. To make a decimal into a percent, you always move it 2 decimal places. 2 places every time. Okay? Any other questions? Because they wanted less than. And we talked about this right before you got here. What if they wanted greater than? If this is 89%, what would this piece be? 11. Very good. How'd you get that? The whole thing is 100, so you just subtract that from 100. Does that make sense? Okay. So, you try this one. Notice that the question says, what's the probability? So, no big deal. I just don't want you to do what? I want you to leave it as a decimal. Just leave it as the decimal. Okay, find the probability that a random value is less than 31. Did I do that right? My bell curve look okay? Sometimes I don't trust myself on a Monday.
So wait, this is the probability.
If you did it right with the z-score and everything. Okay, so I'm going to mark 31. And we want less than. All right, what's the first thing that I need to do? Change it to a z-score. You cannot read the z-score table unless your point is in terms of z-score. Okay, so how do I change 31 to a z-score? Very good. So what would this be? 31 minus 45 over 6. So when we do that, what is your z-score rounded to the nearest hundredth? Well, that's your probability. So 31 minus 45 divided by 6 is negative 2.33. That's your z-score. Because right, exactly. You were telling me the answer. What if you don't do your z-score right? Then you're not going to read your table right. Does that make sense? What if you don't round it right? You see what I'm saying? Like if you round and you go to your table and you're one off, it's going to affect your answer. Okay, so you have to be very cautious, careful, and conscientious on this. Okay, so if I go down to negative 2.3 and go across 2.3, 0.03, 0.0099, yes? So this would be 0.0099. And that's going to be my answer because what did it say? Probability. It's 0.0099 out of one whole. Does that make sense? If I wanted the percentage, then I would move it 2 places and make it 0.99%. So close to 1%. And that makes sense because we know that's what? Is that close to 1%? Yeah, you know this is 0.1 and you know that piece is 2.35, so you know it's going to be, that makes sense to us. All right, last question. Yes. Okay. Let me